In this video we shall discuss how to use stored procedures for performance optimization. In the first task we have to create a stored procedure that is scheduled to update book statistics table every hour. And you may reference the first task of this topic for details about that table. Obviously, the expected result is that each hour this procedure starts and updates this table. Let's start with MySQL, and on the first step we have to create the procedure itself. In the procedure body, first we have to check if this table really exists. If it doesn't, we have to stop the operation. Otherwise, we have to update all data in our table, and you may reference this topic for details. On the second step, we shall execute manual call of our procedure, just to be sure that it works. On the next step, we have to schedule the procedure execution. To achieve that, we have to turn on the scheduler, and then we have to create the event. This event should be executed each hour starting from now, that's how we get current date and time, and on completion this event should be preserved, it should not be deleted. And the idea of that event is to call our procedure. On the final step we have to check if our procedure was really scheduled, so we have to execute such query, and we shall get such a result, and that result with a lot of data will be reviewed in details in a couple of minutes. For now, let's proceed with Microsoft SQL Server, and of course the first step is the creation of the procedure itself. Like in MySQL, first we have to check if this table exists. And if it doesn't, we have to stop our procedure execution. But if the table exists, we may update it, and we may use that query with details described in this topic. On the next step, we shall execute our procedure manually just to be sure that it works. On the next step, we have to schedule our procedure execution, and in Microsoft SQL Server this is not an easy task. You may see a lot of unusual actions here, but each of that actions is described in corresponding section of official manual for Microsoft SQL Server. There is no point in memorizing all that syntax because you may always refer to official documentation of each and every DBMS. And like with MySQL, on the final step we have to check if our procedure was scheduled for real. For now, the main idea is to get such a data, and that data will be explained in details in a couple of minutes. With Oracle the idea is the same, and on the first step we have to create the procedure itself. Once again we have to check if this table exists. If it doesn't, we have to stop the procedure execution. But if it does, we may update this table, and all details about this update query may be found in the corresponding topic. On the next step we have to perform manual execution of our procedure just to be sure that it works. On the next step we have to schedule the procedure execution, and once again all the information about these commands, this syntax may be found in official documentation for each and every DBMS. And finally, on the last step we have to make sure that our stored procedure is scheduled for execution. Once again we'll get such a huge dataset, and that dataset will be reviewed in a couple of minutes, so please be patient. In the second task we have to create a stored procedure that is scheduled to optimize or compress all database tables once per day. Obviously, the expected result is that each day the procedure optimizes or compresses all database tables. And before we begin reviewing the solutions themselves, we have to emphasize that these solutions are provided for educational purpose only and only. Please do not try to use them blindly on your production environment, otherwise most likely you'll ruin your DBMS performance instead of optimizing it. That's because in real life a lot of parameters should be considered before playing with performance optimization. But for now, let's look at the general idea, starting with MySQL. Here, on the first step, we have to create the procedure itself. Inside the procedure body, we have to declare several variables, and this variable is the most interesting one. Here, we are creating the cursor that will return the list of all tables in current database. Please refer to the official documentation on how to get such lists. Then we have to open the cursor, and we have to iterate through the whole dataset returned by that query. So for each table in our database, we have to execute such a little query, optimize table, table name, and that table will be optimized. And generally that's all. Then we have to execute our procedure manually just to be sure that it works. Then we have to schedule our procedure execution. So once again, we are enabling the global scheduler and we are creating the event. That event should be executed once per day, starting from today. On completion, this event should be preserved, as it should not be deleted, and the idea of that event is to call that procedure. Now let's check if both events from this solution and the previous one are scheduled for real, and we have to execute such query. And finally, here is some explanation about data produced by that query. Here we see event name, here we see event type, that it's a recurring one. Here we see that this event occurs each hour and this one occurs each day. We see when both events start and we see that both of them never end. We also see that the current status for both events is enabled and we see that both events will be preserved on completion. Now let's proceed with Microsoft SQL Server, and on the first step we have to create the procedure itself. Like with MySQL, we have to declare several variables, and the most interesting is this one, the cursor for the query that will return us the list of all tables and clustered indexes. Once again, we have to remind that all the information about such actions may be found in official DBMS documentation. Then we have to open the cursor, and for each row in that dataset, as for each table, we may either reorganize the table or rebuild that table or leave it as is if it doesn't require any optimization. So for each table we are analyzing its fragmentation status, and for this case we may reorganize the table, for this case we may rebuild the table, and for this case we may leave the table intact. And that's all with the main part. On the next step, as usual, we have to execute our procedure manually just to make sure that it works. On the next step, we have to schedule this procedure execution, and once again and again, please do not try to memorize that syntax. You may always refer to official documentation of each and every DBMS. Finally, we have to look at our current scheduling status. And here we see information about both of our events in details. Here we see the names of our events, their status, that they are enabled. Unlike with MySQL, the information about scheduling details is not so obvious here. For instance, these numbers are not human readable, those are just technical numbers. But at least we may see the date and the time of the event start. And let's continue with Oracle, starting with the procedure creation. Like in both previous DBMSs, here we have to create the cursor for the query that will return us the list of tables in our database. Then for each row in our query result, as for each table in our database, we have to enable table optimization, we have to optimize the table, and then we have to disable the table optimization. As usual, on the second step, we have to execute our procedure manually just to be sure that it works. Then on the next step we have to schedule our procedure execution. We have to create a job on the DBMS scheduler, and you may find details about that syntax in the official DBMS documentation. Finally, we have to check the scheduler status, and we may achieve that by executing such query. This query will return some useful information. Here for both events we see their names, we see that both events are regular ones, we see that idea of that events is stored procedure execution, and we see those stored procedures names, we see that both events are enabled, and for each event we also see the start date and time and repeat interval.